Thanks for joining, everyone. Welcome to our 10th Quantum Delft seminar in the series. As you can see, we've had to go back online due to the corona restrictions, but really glad you can all join us. We have, for the last 3 seminars or so, we've had an international flavor to our meetings. We've had guests from France, from the UK, and from Denmark. And we're continuing that theme today. We have Ramiro Sagastizabal from Qilimanjaro Quantum Tech. He's a senior quantum engineer there. Before I pass over to Ramiro, for those watching on YouTube, if you have any questions for Ramiro or Niels or the discussion later on, please put your questions in the chat function and we will add them into the stream as we go along. But I'm very pleased that Ramiro can join us today. As I said, he's the senior quantum engineer at Qilimanjaro. Qilimanjaro is a spin-out from the Barcelona Supercomputing Center, University of Barcelona, and the Institute of High Energy Physics. We're really glad you're here today, Ramiro. For those from the Delft community that thinks he looks like a familiar face, that's because he has been doing his PhD at QTech in Leo DiCarlo's group, and very close to the end, I hear. So, Ramiro, the floor is yours. Thanks very much.
So thanks a lot, Dan, and yeah, thanks a lot to everyone for inviting me. And yeah, as you were saying, I might look like a familiar face because I did my PhD at QTech with Leo DiCarlo, and now I'm basically organizing the defense. So stay tuned for that other QTech event. And well, as you mentioned, I was in Leo DiCarlo's lab doing superconducting qubits, so hardware work on transmon technologies. And after that, I moved over to Barcelona to this startup called Qilimanjaro that I'm going to be telling you today about. So I moved up to this company at the beginning of this year, but this company was early founded in 2020, although we started our activities in 2021. And we are a spin-off of 3 centers where three of the founders do their daily jobs as researchers, and well, one of them is actually a director and stuff. One of them is the Barcelona Supercomputing Center, which is a high performance computing, a supercomputer facility. It's the biggest supercomputer in Spain. The other one is the High Energy Physics Institute, DeFi, of the University of the Autonomous University of Barcelona. And this is where the hardware work is focused, where we have labs along with the research team of one of our founders. And finally, the Universidad de Barcelona, where another one of our founders was based. And we work all across the stack. So we are a quantum computing company. We work all across the stack in manufacturing quantum computers and developing the controls stack for the software. So we work on the quantum hardware for design, fabrication, characterization of devices. We also have a team working on the quantum software side of things, algorithms, and the architecture of our designs and our devices. And finally, of course, we have a classical software team. They're working on the code that mounts up the entire stack of software we have. So just a bit about our founders. We actually have quite a lot of founders. We have 5. And so, as I mentioned, 3 of them, La Torre, Paul Fondias, and Artur Garcia, are actually scientists with their research teams. Maybe a nice curiosity, Paul Fondias actually did his PhD in one of the labs that is nowadays QTech, but back then it was not. It's the lab of Hans Moy, where the flux qubit was invented. And then we have other 2 founders, Victor Canivel, he's a physicist by training, but he has dedicated his career to the management side of tech companies. And Jordi Blasco, who's actually handling all the legal aspects. He's a lawyer and he handles all the legal aspects of the company. So a bit of what is it that we do? Well, as I mentioned, we do works all across the stack, and we have quite a nice luxury, which is that of having existing contracts. It's typically quite hard for a starting startup to secure funds without promising the moon and so on, and focusing on being able to focus on their product. So we have the nice luxury of having existing contracts. On one hand, we have a quantum software contract with Stuart. Stuart is a French delivery app, so it's one of these apps where you have someone logs in and asks for a delivery, and you have to assign a rider to do that delivery. And we also have an existing quantum hardware contract that actually turned out quite nice, because it's not only a contract, but it's given rise to a partner of us over in Abu Dhabi, in the United Arab Emirates. And of course, we have our own agenda of what we want to bring of novelty to the quantum computing market. So I'm going to be detailing a bit more about these two things. And well, on the existing contract side, what this French delivery app Stuart is doing is they're wanting to explore how to improve their algorithms. So it's all about algorithms of how to assign riders to newly routes that are demanded by clients, and not only how to explore not only about exploring how to profit from quantum computers, but also as well from getting quantum inspired algorithms, which are classical algorithms inspired on quantum based way of thinking. And actually, well, I do hardware. That's what I handle in the company, and that's maybe why I'm gonna give you a lot more details about the other one, which is also one of our bigger contracts. This Abu Dhabi Technology Innovation Institute, where what they were wanting was not only to be delivered quantum devices, which we are doing. We are right now on track, and it's helping us progressively ramp up also our capabilities. But also what they wanted was to be guided to know how to plan a new facility from scratch, both in terms of laboratory and clean room facilities, and also how to train their people, how to develop their knowledge so that they can control these devices we deliver them, and do their own explorations with that, and with their clean room, of course. And this has come to be quite a nice way to kickstart our activities, because this fit perfectly with the initial ramp up that we had to do. We were also starting with a lot of facilities from scratch. We were also starting to interact with a clean room in Barcelona that is very nicely equipped, but not having so much quantum production know-how. So we have been building that up quite a lot. And along this year, we have managed to fast track all the way through single qubit devices. And now we're working at this last quarter on 2 qubit and 5 qubit prototypes for this. This is all gate-based devices, transmon technologies. And as I mentioned, this did not only consist of delivering qubits, but also allowed us to develop quite an interaction with these guys, and to be to promote a lot of activity with them as well. So you may see these announcements on the United Arab Emirates first quantum computer. That's our collaboration with them, our contract. And now let me pass to how this fits in the larger scale, in our own agenda of what do we want to bring in terms of novelty, in terms of our product within this quantum world. And I mentioned the words coherent adiabatic algorithms on superconducting hardware, and I wanted to break that down because each one of these words is chosen because it's relevant in a certain sense. Coherent, of course, because we look for quantum advantage, and we think that in order to achieve that, we need our algorithms, we need to aim at algorithms that survive our coherence, that are shorter than it. This might seem super trivial, but previous attempts on adiabatic algorithms have completely ignored this. So this thing that seems completely basic is quite important. Secondly, I mentioned adiabatic with that little trick of words with the die of diabatic in parentheses. That's because we want to use quantum devices, NISQ devices, within the adiabatic paradigm. And that means instead of using gates, and I'm going to elaborate a bit more on that in a few slides, instead of using gates, we want to evolve the system to a target Hamiltonian, which our beloved quantum programmers tell us it's interesting for a certain reason, and measure the system at this final point so that we can interpret that in terms of a solution to a problem. Now, what literature tells us is that it might be very important to not only stay in the adiabatic paradigm, but to spice it up with small diabatic shortcuts. That's why I use the term diabatic, add diabatic with that parenthesis. But also, why do we want to do this is because this paradigm relaxes several of the constraints in the gate-based approach. And finally, on superconducting hardware, because we intend to use flux qubits, which were actually invented in Delft. These flux qubits are a sibling technology to that of transmons. They are superconducting qubits based on Josephson junctions. So let me organize this a bit more in a more concise agenda. Specifically, what we want to do with this is to bring practical applications on NISQ devices in a shorter time frame than that imposed by pursuing error correction schemes. We plan on doing that through this adiabatic paradigm. And what I was saying that I would give a bit more substance on it is that, contrary to the gate-based approach, the gate-based approach focuses on having these nice concepts called gates, conceptual units called gates. There are certain action on the qubit state. And then the quantum programmer task is that of figuring out the smartest way to orchestrate them in time in a circuit or an algorithm. Now, in contrast to that, adiabatic algorithms are about starting in a certain Hamiltonian of your system and being able to identify a target Hamiltonian that is interesting for some purpose, that is well studied. There are a lot of interesting target Hamiltonians towards optimization tasks. Now, having identified that, what you want to do is you want to evolve your system in an adiabatic trajectory up to that final state. And that's the adiabatic program, the adiabatic paradigm. And the task of the quantum programmer in this sense is different. Is now to identify how to transit from this initial to this final Hamiltonian. And what are the challenges towards that? Well, as I mentioned, coherence matters. So that's important. So for as long as we keep pursuing coherent technologies like the flux qubits we're aiming at pursuing, we are fine, but it's important to not lose it from sight. And in terms of quantum advantage, in terms of interesting problems, what does that mean? And what really matters are two key concepts here, which are that of non-stochasticity. This gets quite technical, but basically it describes certain Hamiltonians that, up to our knowledge, are very difficult to simulate. And the up to our knowledge part is where the technicality gets a bit more tricky. So identifying couplings that implement non-stochastic Hamiltonians is very important. And as well, this diabatic spice I mentioned, which is to not just stay always in the same state, which would be just being adiabatic, but also eventually, every once in a while, with certain frequency, going out of this state and coming back. That's what makes for a very hard problem to solve classically, to simulate classically. So that's where the hopes of doing something interesting and useful are. And this key component that I mentioned, the flux qubit, is actually very interesting because, first of all, it's a very close technology to that of the transmons, which are very well understood in literature and in the community. So we think we can really mount the fabrication and the control techniques for such a qubit. And also because the coherent times are sufficient to start thinking about doing interesting things within this time frame. And finally, there's a very specific flavor. There's a very specific detail of why this is interesting and needed for and necessary for adiabatic algorithms, and that is the fact that with flux qubits, it's easy to measure them out of their sweet spot in the basis of their sweet spot. The basis of their sweet spot is that of signs of circulation of current in a squid loop, and the fact that we can measure that very easily with other squid loops, auxiliary squid loops, out of this sweet spot is what allows us to measure the state of these qubits after the annealing schedule, the adiabatic schedule. So this a bit summarizes what we aim at doing. Where are we now? So after this tremendous first year, we are now working on 2 and 5 qubit prototypes. That's with respect to transmon technologies. And we just had, by our collaborators on this research group at IFAM, gotten a first prototype on coherent adiabatic annealers, which are that of 8 disconnected qubits. And that we are just testing since, I think, last week. So I don't have many details on substance on that. I'll keep posted on that. And finally, where are we going? Where do we want to be? Well, we want to keep scaling in terms of the gate-based, the transmon technologies. Our current goal for 2022, and we strongly believe this is achievable, is 10 qubits by the end of 2022. And with respect to coherent annealers, of course, what remains to be done is these 2 very important spices, the non-stochastic coupling, so that we can couple these qubits, and to be more efficient on the control. And that brings me a bit to one of the things that makes today interesting, which is we are very heavy on collaborations, and on this case, well, our partners and friends are the guys on Qblox that you will hear in next slides. But I wanted to say that one thing very important towards this is that ecosystems matter, that it's very important to do what you do very well, but if you want, as the saying goes, if you want to go fast, go alone. If you want to go far, go together. So we also have in Qilimanjaro a big interest and a big effort on building and developing the ecosystem over here in Barcelona. So we are building a new master's program in collaboration with the Universidad de Barcelona and with several institutes, including ICFO, IFAE, and many others. As I mentioned, we are actively collaborating with institutes. And within the Europe sphere of things, we are collaborators in a big consortium called Abacus. Abacus is a consortium to develop these coherent adiabatic processors, along with several other institutes in Europe, including the Karlsruhe Institute of Technology, and some guys you might know, the Delft Circuit guys. And then, of course, we have partners and suppliers. We have a very nice relationship with the Qblox guys over here, and we're talking further with other guys you might know. And of course, as I mentioned, we over the world, we have clients and collaborators. We have an existing software collaboration that includes the Quantum Computing Center in Singapore and so. And well, I think I'm really eager to discuss further how to involve and develop further these ecosystems. So with that, I want to thank you, maybe open for questions, and yeah.
Thanks very much, Ramiro. That was a great talk. I don't see any questions yet. I'm just looking at the feed. So if anyone watching live, you can put your question into the live YouTube chat, and we can bring them to Ramiro. One question I have, obviously, Qilimanjaro does the software and hardware full kind of stack approach. I'm just curious how effective it is to have the hardware and the software so closely connected in a company. How does the company operate in a way to really maximize that connection?
Yeah, well, that's actually an amazing question, because that's one of the challenges in a certain sense, and but that's also one of the opportunities in the other sense, right? Because of course we first of all try to be sustainable as each group by itself. meaning we try to do things that we can do irrespective of whether the other team is glorious and achieves everything, right? So to that extent, we have contracts in a different manner, in a different capacity. So we focus a lot on the hardware area, on the contracts with Abu Dhabi, but there's also a software side to the Abu Dhabi collaboration and the clients, and there's also the software side of this Stuart company in France. So we have kind of independent agendas to a certain extent. But of course, there is the critical part of putting everything together so you can add further value. And that's what there's this term that everyone keeps bringing about, and it's the term of co-design, which is the term of it's the concept of maximizing how much you can do by knowing what the other one wants and what the other one needs and what are the difficulties of each other. And to that extent, it's very important. We are actually having a 2 yearly hackathons now, so that we kind of put together all the brains in the company to kind of generate these synergies. And of course, towards building a nice product which we are building, which is a quantum as a service, to have something like the Quantum Inspire you might know over there at Delft. That needs a lot of interaction and actually co-design specifically. So I think I haven't answered, and it's the one thing that makes it more interesting. Is it dangerous? Is it not? And I think at every point in a, not only in a startup but also as a player, either a research team or whatever, you need to ask yourself in the quantum environment, you need to ask yourself, what can I do very well, and how can I interact with others that do other things very well? And even if they don't do other things very well, they do the same thing very well. Is there a way to promote together developing things? And those discussions are something I don't have the final solution to, but I think it's very important to have people that are on this kind of, that are considering this kind of aspect seriously and as a part of their job. So we have, that's what Victor Canivel does for us by managing the business development kind of things. Which is to be very open about these things. A funny story is that actually my colleagues and very good friends from the PhD in Delft actually found Victor earlier than they found me for collaborating. That's a funny story, but I actually really like it because it means we are actively trying to identify opportunities like that. I don't have a final definite answer for that. I think it's something very human related and the kind of thing that we need to solve together by putting people together in a room, right?
Yeah. And for example, the Dubai work that you're doing, is that you're not just providing the chips, so you're building the entire quantum lab for this institute?
So it meant that it's not just building it's not just getting a building, it's about getting a building with infrastructure to support a fridge, to have the nitrogen facilities, the all the necessary installations for the chillers and the electrical support for it. And a clean room is even fancier in that sense. You need the air handling system and everything. So to properly plan that and make sure that it will suffice for the plan over the coming years on their interests of pursuing, they want to play on this field, they want to get involved, and they need to start from somewhere. And surprisingly, it's very difficult to bring people over to Abu Dhabi. So if anyone is interested, contact us. But yeah, it's very it's not only about handing them out them over the chip, but it's also about getting them up to speed and to become a player within the human sphere of things.
Yeah. Okay.
Yeah.
Great. Well, I think we're ready to move on. We'll come back to you, Ramiro, in the discussion bit in a minute. Thanks very much. That was a great talk. So moving on, we're going to move to Niels Bultink, who is the CEO and co-founder of Qblox, which is a QTech spin-out. Normally, I would say Niels is just down the corridor from me and, local in Delft and everything, but he's today joining us from the west coast of the US. So it's bright and early for him. Thanks, Niels, for making the effort, and the floor is yours.
Great. I'm very happy to be here. Although it is indeed very early, but no problem. I want to ask Julia, did the slides work out? Yeah. Wow. Amazing. Amazing. There were some issues with uploading the slides, but it just came right last minute. So actually, I wanted to start a little bit with some holiday pictures, because right now we are with Qblox with a small team in the West Coast, which is really good again to be traveling, to be able to visit people in reality. And also a few weeks ago, we had the opportunity to go to Spain, to Barcelona and Bilbao. So I'll also share a little bit from that. So first, yeah, we're right now. I'm reporting from the West Coast, where we have been with quite a good delegation from Delft and from the Netherlands at this conference called Q2B. So on the far right side, you see one image of that conference where I was shortly on stage to address the folks there. But there was really a large body of people from Delft, and which was very good to see that our ecosystem is so well represented at these international events. And now what we're doing with Qblox, we took the opportunity not just to go to this conference in San Francisco, but also visit a few companies and institutes around, like Berkeley, Rigetti, at the San Francisco area, but we also just came from Santa Barbara, where we were able to visit Google, and now today we got the chance to go to Amazon here in Los Angeles. So Los Angeles is known as an extremely sunny state, but it is raining very hard at the moment, so not a lot of luck there. And a few weeks ago, we had the opportunity to go to Spain, as you can see here, where we were on a conference. And in the middle, you can also see that we were next to Ramiro with Qilimanjaro in his booth. So it was very good to be side by side on a conference, like working with the two companies together, not just in the lab, but also to be at a conference together and work together on how we can boost the ecosystem. Another great visit we could do in Barcelona. So the conference was in Bilbao, but we went to Barcelona to visit EFIA and also Qilimanjaro. But we also got to see this amazing supercomputer. I'm not sure if you guys have seen the Dan Brown movies, but this is a supercomputer that is embedded in a church, and it was quite amazing, because yeah, that's not your typical supercomputer. Yeah, we hope that one day there might be a quantum computer also next to this in this building. So it also had a business side of visiting this place. So that was a little bit about Dutch-Spanish collaboration, but also I want to share a little bit of the roadmap of the capabilities of Qblox, what we're doing, where we are heading, and I'll try to keep it short because I especially want to open the room for questions, also more to Ramiro, to us about the collaboration. So, what is it we are most aimed at? I think the whole quantum computing field is in this two-dimensional battle, where we need to go from this bottom left few qubits that have a lot of errors. We want to go to quantum advantage, and this requires really a two-dimensional battle. So increasing the numbers of qubits of quantum material, just a sheer scaling effort. And on the vertical side, we need to reduce errors in the system. And in the control stack, what Qblox is working on there is really a great challenge in these efforts, but also on many other aspects of the stack. So for us, the fact that now many companies are moving away from this idea that they want to do everything themselves, so this vertically integrated approach where they build their own fridge, cables, electronics, software, all these layers they wanted to do in-house so far. But now many also of the companies that are already for a long time, institutes that are already for a long time in quantum computing, are now moving away from this idea and start to understand that specialization on many aspects is very important. So I think that's very good for us as a company, but also for the many companies in Europe, in Delft, that are more thinking of quantum computer as a supply chain, as a value chain, where you can pick a strategic position. So for us, that strategic position is the control stack. We are doing that. We're focusing on that since 2018, since we spun out from QTech. Yeah, of course, you guys all know the ecosystem in Delft, so I don't have to say much about that. On the right side, Qblox has since 2018 grown to quite an international company, where we are supporting now more than 25 labs, in both industrial labs as well as academic labs. A few of them you can see on the slide, with, of course, Qilimanjaro in that list as one of our earliest supporters. So that's really a great companionship. Our team has grown to a bit over 20 in January, and with many vacancies ahead. So we really the work is piling up everywhere. So we're really hiring to strengthen our team further, with positions open in physics, but also in computer science and electrical engineering, and also more commercially related roles, of course. And lastly, I want to talk a bit about the technical aspects. So I want to highlight a few things on how we are now able to control roughly 100 qubits per meter. So that's a meter of electronics, meter of 19-inch rack space. That's the products we are now on the market with. So yeah, the issues in control stacks are quite easy to grasp if you just look at these two pictures from very well-known quantum efforts at IBM and also at Google. The control stacks are very bulky, very expensive, and also quite slow to operate. And all of these different aspects we are tackling with our new technology, and we try to grasp that under three themes. One is the stack being fully integrated. The second is about analog excellence, to reduce the errors in systems and also to reduce the drift of calibrations. And thirdly is a fast and open workflow to speed up experiments and to get the results in experiments as fast as possible. That's very important, especially as you are growing your growing setups. So about this fully integratedness, it is quite easily grasped in this picture, where on the left side you see a whole bunch of devices that people now need to use to control 20 superconducting qubits or quantum dots. You need readout analyzers, local oscillators, AWGs, spectrum analyzers, perhaps also a central controller, as has been invented in Delft. And this whole pile of close to 100 devices and 120 wires can now be replaced with this one modular device that's called the cluster. Yeah, and if you think about a few applications, you always have to think of how do you compose the system with the different modules that we provide. So we have 4 of these different modules. With on the left side there's 2 baseband modules, a baseband control module for a baseband to create baseband pulses, so often for flux pulses or for metallic gate pulsing. And on the bottom left, a readout module where you can create readout pulses and also absorb them. And in this case, it's at baseband. And on the right side, you see really where we are. We're a first mover on making a very integrated microwave modules. So from these modules, we can directly pulse qubits between 2 and 18.5 gigahertz. So driving single qubit gates or driving readout directly at in the microwave regime. Yes. So with these 4 modules, we can compose a different type of control stacks for different applications. To give you two examples, here is a superconducting circuit example where we picture here a 4 transmon qubit device where we need just 4 modules. So it's just a fifth actually of the box that is being used to do all the control and readout tasks. So here on the top you see microwave driving of each individual qubit. Then there is a readout module that does reflectometry or transmission type measurements here through a feed line. And on the bottom you see the drives required for 2 qubit gates, where the only task that's separated from the cluster is a DC biasing module that we also provide in the SPI rack. That is very well known to you. Similarly, here an example for a 5 quantum dot device where we are also just using a few modules to do all the control and readout tasks. Yeah, so a lot of the things about how to make these systems convenient and make them fast is about this integratedness. So here you can see one example of this microwave module where on the right side you see that on the analog side the op conversions towards microwave regime is all included in this same module. And this allows making this more easy to use and faster to set up. But also it brings up some advantages in terms of how good of signals you can create with this. Because we can bring all calibration routines on board to calibrate these microwave stages. It makes up for a much simpler and better integrated system. So that leads to a better spurious free dynamic range, as you can see here on the left side. So you can create very pure tones without many additional sidebands that can hit other transitions that you don't want to hit. And other parts of the analog chain where we really try to excel is on the noise levels. So on the top right you see the noise levels of the baseband pulses. That is very important to create high fidelity 2 qubit gates. So 1/f noise from these modules is notorious, or from AWG is notorious in many systems to be a key contributor for 2 qubit gate errors. So that's where we really focus on having low noise. And on the bottom right, you can also see that it's not just low noise, but also low drift. So that large systems are often spending a lot of time calibrating and recalibrating, and by making these drifts orders of magnitudes lower, you can avoid all these calibrations to a large extent, at least as far as they are rooted in the electronics. There can also be other parts of drifts, of course, in the sample itself, but the electronics should be as little contributor as possible. So how to use this equipment to create a very fast and open workflow. So the first step is understanding a bit how you create sequences of pulses or sequences of voltages when thinking of either superconducting circuits or NV centers or quantum dot applications. You always need to think about how to sequence signals. And at the heart is the sequence processor. On the left side of this picture here, picturing one module, and the sequence processor actually comes from the TNO developed central controller, the Q1 processor developed by Wouter Vlothuizen. We're using this to sequence all operations in these modules. We actually use a lot of those sequence processors at the same time, and where they were used at QTech just to sequence QASM-like operations, so sequence pulses. We also used to sequence a lot of other things, like amendments in the digital signal chain. So the sequence processor triggers pulses as a function of time, but it can also amend these gain settings or offset settings, or it can adapt the phase of the real-time modulation. And all of these features allow to express experiments much more efficiently. So it is all in mind with the idea that the more efficiently you can express an experiment, the faster they run. So you want to avoid uploading a lot of memory into the control stack, large waveform patterns, if you can just do it by a more efficient way. So thinking of offset instructions, for instance, to create charge stability diagrams in a much more efficient way, or thinking of phase settings to do virtual Z gates and those type of things. So this is all about parameterization of the operations. So and here you can see one example where we speed up a chevron experiment from 1.5 hours to just a bit over 10 seconds by using all these sequence processor capabilities. So one last part I want to address technically is this easy and open workflow. So of course you have all this processing power, but you also need a user-friendly way to access it. And the logo of Orange Quantum System has dropped off the slide because there's no animation, which is behind on the left. So we work together on open source software together with Orange Quantum Systems in this so-called Quantify package that is completely open source available and has many contributors. And it has many tasks like sequencing all the experimental operations, looping over different parameters from a software perspective, doing automatic optimizations. And one other task of it is how to schedule on a nanosecond time scale all the operations in our devices. And you can see on the left side a little bit how this is done. So you always start at a high level intuitive programming interface to schedule gates, but also can be pulses or arbitrary voltages with an intuitive programming language that then compiles to a visualizer to see all those voltages as a function of time being represented in a simple Python interface. And that also compiles then to all the more assembly code, really the low-level code that runs on our devices. But some of our customers don't use all this software at all. They use their own compilers and directly use our assembly language to compile towards. I think also at QTech this might be for some labs a more interesting approach because there's already a long tradition of building compilers, and then making these transpile towards our assembly language is also very convenient. Okay. So now think a bit about the Moonshot projects we are in. One is about scaling up these systems even much further to address more numbers like over 1,000 qubits. That's where we are further downscaling the electronics and also working on things like real-time quantum error decoders. We do that in collaboration with also quite a few entities to make sure that our devices can be tested in a real good setup. And lastly, we are being involved in the Quantum Internet Alliance, also with Spanish entities from Barcelona, from ICFO, where we are driving and connecting many quantum network platforms like trapped ions and V centers and these rare earth ions in Barcelona. I always have a hard time saying that. In short, we have a lot of collaborations around the world, also very good ones in Spain, and we are working very hard on supporting experimental progress in the world. And I guess we also have a lot of fun doing so. The collaborative spirit of the company is really, for me, is very exciting to be in because it allows us to interact with many entities in the world, get to know a lot about the different thoughts, ideas in research, and also, support Spain, support the Netherlands in its research. So with this, I'd like to open the floor for questions. Also open the floor to Ramiro to join in, I guess. But then maybe you can pick up the ball again.
Thanks very much, Niels. That was a great talk. Thanks for the update. It's good to know what Qblox are up to. We don't have any questions. We've got a few comments in the chat, but no questions. If anyone has any questions for Niels or Ramiro, please put them in the YouTube chat. Maybe if we can add in Ulrich as well. I'll just quickly introduce Ulrich. Ulrich Mons is the responsible for international strategy at Delta. Thanks for joining us, Ulrich. So I guess the first question, which I guess is aimed at Niels and Ramiro, is what kind of events have been most valuable to both your companies in terms of enabling these connections that grow into collaboration? Niels, I'll go with you first.
So honestly, in real life events, that's for us over the last few months, that has been very valuable. You can connect on such a different level with people. That's it's about spending more time, but also interact more on a non-business side as well. That's for us very valuable to be able to do a bit again, as long as we can. And what type of event? So to me, the more technically oriented events or scientific events are for me personally always nicer than the more business type of conferences. But that's also a bit my personal taste. We have technical solution, and we're always looking for technical problems where they can apply. But that's
okay, great. And Ramiro, from your side?
Well, I guess I resonate on the in real life event things. So of course, you can know, because we have been interacting. For example, I'm taking the Qblox Qilimanjaro example, where we have been interacting quite a lot. They were being suppliers of us, but we knew we wanted to go further and collaborate and be partners on further things. But of course, the chance to meet with the person and interact at the beyond email level or beyond the Skype level, that's helped quite a lot. And I think over the last some weeks ago, when the guys from Qblox visited us, it was really helpful towards building not only interests together, but also getting them to know each other, with the people that did not know them from the PhD like I did, right? I think that's definitely important. I think in the end, things are about ecosystems, and this is about ecosystems. This is about people not only doing the technical thing, which of course I coincide with Niels. We are technical guys that are very susceptible to this XKCD joke nerd sniping, to being triggered by a nice technical problem. And but I think it's really, human bonds, human linkings matter as well. I see that now we have been joined as well by Victor. I briefly introduced him on my slide. He is the business developer and manager of Qilimanjaro. So maybe I let a bit to hear his opinion.
Yeah, yes. Victor, the question is, what kind of events have been most effective for Qilimanjaro in terms of building connections and building these collaborations that you have with other companies and other entities?
Well, first of all, thank you very much for the invitation. Sorry I couldn't join sooner because I would have loved to follow the whole discussion. So in terms of the events, in many ways, I would say to begin with, we are still very much connected to academia. So being very tightly connected with the academic networks is absolutely crucial to us, because many of the ideas, many of the new inventions are still coming out from academia. So, and this will continue to be the case for quite some time, because this is a very much of an evolving target, evolving technology. So that's point number one. I think it's absolutely crucial that we continue to be connected tightly with the world of academia internationally, across, in our case, across Spain, across Europe, and internationally. Now, in terms of other events, in the world of looking at it more from the point of view of, I would say more from the business side as opposed to on the purely academic side. There are a number, as you know, a number of conferences which have come into existence recently with the last couple of years, right? So there's, in Europe, there's a couple of them. In North America, of course, they're quite active. Everywhere there seems to be some new events. These events are interesting because, first of all, for the exposure, for all of us which are in many ways starting up our new businesses. So we need to get to be known, and therefore we need to be there. But more importantly, I would say it's to actually connect with the rest, because none of us can go it alone. I guess this has been already mentioned many times in this session. There are many different layers of technology that need to be developed, and although startups, in these early steps, and we are one example. In many ways, when people ask us, "What do you do?" So we say we are a full stack startup, which is very ambitious, right? Because we're trying to address everything, from the qubits all the way up to the algorithms that make these qubits to make the most out of the qubits we have today, and to their specificity. So from that point of view, we need to be full stack. But on the other hand, we all know that in our destiny, we all specialize. We all end up specializing. And therefore, today, we need to be tightly linked and understand which are the other enabling technologies, which are the other components that we all need to use. For example, we are working very closely with Niels, as I believe Ramiro has been saying in the past, right? So we need this kind of electronics. We need, in fact, moving forward, we need cryogenic electronics. We need to work very tightly together with the refrigerator industry. And then if we look at the world of software, again, there's a lot of open source code floating around. All of us are developing open source. All of this eventually will become more or less unified and stabilized, and then we have different layers, and everybody will specialize on a different layer. So we need to be at these events so that we get to know each other. We learn what is being developed. Things change very quickly. How can we leverage the best? And then create these alliances, these consortiums. And let me say, in closing this first question, sorry for the long answer here, but we are extremely at Qilimanjaro. We believe very, very firmly that we need to develop an ecosystem here in Barcelona. I mean, we look at you and are looking at you kind of collectively as coming out of Delft. And we admire these steps and the situation that you have been able to develop over the years, in terms of the research institutions, all the publications, all the technology that's been developed, and the companies that are coming out. And that's what we would want to replicate, of course, in a different way, in a complementary fashion, over here, as is going to happen in many other places around Europe and around the world. But we know that to be successful, we need this ecosystem, and we need one in town, and we need one across Europe. And we very firmly believe that, given the origins of some of our people, like one of our founders is Paul Diaz, who made his PhD, as you know, in Delft 10 years ago, and Ramiro now, and Daniel is joining us also now. So there's a lot of natural connections of people that are working with us, and of companies that are already working with us, like, for example, Qblox. But I mean, there are other companies in Delft that we're also working with. So this is absolutely critical. And again, sorry for this long diatribe.
That's great, thanks. No, I think it really helps set the scene of what's successfully working in Europe right now. Obviously, Niels, you're in the US. You've been at Q2B, and Ulrich, you were there last week as well. I'm curious, I'll come to you, Ulrich, first. What was your view of how things are in the US? What are they doing well, and maybe what is it we can learn from, especially the kind of their startup scene and the kind of ecosystem, as Victor mentioned?
Yeah, thanks, Dan, and thanks, Victor and Ramiro, for your thoughts. I mean, Niels, you were there. We had a large delegation from the Netherlands. There were, due to COVID, not as many people from Europe as you would otherwise expect. The interesting thing always in the US is that they are very very clear in their ambitions. The startup scene is pushing forward quite fast, I think. I've been there for the last 3 years, and you can see the rise in ambition in that sense. And the Q2B is a good conference to sort of gauge where it's going. I think the European ecosystem has a lot to offer, and I think what we're trying to do as a national program at Quantum Delta NL, we're trying to look for the best, for the visibility for these collaborations. For example, Qblox and Qilimanjaro obviously being an excellent example. How do we grow this? How do we make this happen more often? And how do we make it visible to others? Also in the US, I think there's a lot of work that still can be done. We're looking for the ways to facilitate that. When you go to these conferences, and Niels mentioned the dilemma between academia and business at this point, and how much do you go into tech and how much do you go into the business side of things. It's an interesting balance, right? And I think in Europe we have to do both, but we probably have to grow the business aspect a little bit further, because you can see that where there's interest in the US, it comes from the business side, and that is shifting the way quantum is being talked about at this point. I'm not sure, Niels, you might have a couple of additional thoughts on you met a lot of people as well, of course, and over the last couple of days as well. I'm already back in Europe, but you're still there.
Yeah, no, well, I second a lot that you said about the conference, and I want to add one thing. I think actually looking at startups coming out of university or new startups popping up, I think Europe and the Netherlands are actually doing very well, and I did not see such action coming from the US a lot. Also, what I typically hear is that the climate for starting companies is actually very good in Europe. So I think you guys have done a very good job, both in Spain and in the Netherlands. But where the real action is in these few startup companies that have started there and are really massively growing and have massive investments, and that's something for us to catch up to. So I wouldn't call it a wake-up call, but it is good to remember that there's not just in the US, but a few places around the world are really investing heavily, and we always need to step up our game. So that's
there's homework to be done. I mean, that is the takeaway. But again, there's a lot that we can show for, and I think we can make it more visible. Absolutely. And one of the questions, I mean, you all mentioned the word ecosystem, and that's obviously the bread and butter of our presence here in the Netherlands. I'd be curious to you, but also to the rest of the group who's watching this now and later on, if you look at the kind of events that we can facilitate, because we can facilitate events. Sure, conferences, we have them, and we'll probably get more of them. We'll get more specific conferences down the road as well. We got the IQT on quantum internet specifically in February, for example, in Delft, and there's much more coming up. But Ramiro, you mentioned hackathons, for example. There's other events you could imagine, for example, to connect to European funding schemes, maybe just meet up in Brussels or having dedicated other meetings, having fellowship type programs, for example, where people don't meet for a day or two, but maybe for weeks or even months. What kind of programs would help making these connections meaningful? You don't have to answer that now, but I think that's a general invitation to send us with your ideas and your wishes.
I have to jump up with crazy ideas that I sometimes have right now, and it just one of those popped in my mind. So take it with a grain of salt, let's say, with a bit of caution. But I just thought, one thing that as a Latin American, I always admired from Europe, and I thought it was nice in the context of academia. This was in the context of education. I always admired the Erasmus projects, the Erasmus movements, right? To the extent that when I came to Europe, I found out that a lot of people were out on Erasmus, and that promoted a lot of connection with a lot of countries from Europe, with students, right? And I just had the crazy idea. I'm not saying it's actually even possible. I'm just saying I think that the fact that activities about humans circulating and to promote the exchange of humans in a certain sense, it's I think that's definitely one of the things, because and I'm thinking that definitely resonates to what we were talking with Niels about, the face-to-face, the human contact in real life really helps.
And the longer ones, not necessarily
yeah,
the 1 to 2 days, but the weeks and months to make
Quantum
sure.
Erasmus, I don't know, I'm thinking out loud right now. But for example, we have an interested master student that for their internship, he wrote to be in Qilimanjaro. He's doing his master's project in TU Delft in QTech, in the Quantum Master's program. And for his internship, he requested Qilimanjaro. I think that kind of things can really promote, having people flown back and forth, and, having people that have spent some time doing some hardware work in Qblox, joining to use them on a coherent quantum annealing algorithm. That kind of thing really gets more likely to occur if you have a exchange of people. I think to that extent.
Let's set it up. It's a good idea.
Yeah, that's a big thing that we're looking at for Quantum Delft, is to build these opportunities for students to connect to companies, to create those opportunities, not just within the Netherlands but internationally. And we'll be happy to discuss with Qilimanjaro about bringing you guys in to connect in that way. I think that would be a really good approach.
That would be great. I think this is something which is very useful. We've begun to use this also locally, as I guess you've been doing for some time, I'm sure, with summer interns from the local universities. But I think this idea of a quantum Erasmus that Ramiro just brought up, I think is a great terminology, because just to facilitate young scientists to spend 1, 2, 3 months in their academic year working in a company in a different location in a different country, I think will be extremely useful. This is something which already exists probably, but maybe we can formalize it, we can support it, we can give it more visibility, and we can specify it on quantum specifically. I think this certainly will help a lot. I agree.
Great. No, I think that's a very positive note to end on, given the time. So that leads me to thank all our speakers today for joining us, as well as Julia, our community manager, who's behind the scenes directing all this. Thanks, everyone. I hold my hands up. I appreciate that this hasn't been the most diverse panel of speakers. We do like to try and make these panels as diverse as possible. That's our responsibility, and we're looking to improve on that in the future. But whilst we're still in Corona times, the early new year, we will have a few more of these virtual events, and then hopefully come the spring, we'll be looking to get back to more physical events, as we mentioned, the power of the physical events, and hopefully we will have a House of Quantum 1.0 in Delft, new headquarters, to be able to welcome everyone there. So it leaves me to say, wish everyone a very happy and healthy holidays. Thanks for joining us, and we look forward to seeing you all in the new year.
Thank you very much, Daniel. And let me add just in closing, so thank you very much for the invitation. And let me also extend our invitation to all of you to come to Barcelona whenever this is possible and you have the time and the interest. We'd be very happy to host you here to show you what we're up to, both on the supercomputing side and on the quantum side, and get to know each other more and learn from each other. So anyhow, this is an open invitation. We can discuss this in the new year whenever it makes sense.
Thanks very much, Victor. I love Barcelona, so I'm sure I'll be taking you up on that as soon as possible.
I can definitely recommend that. Having had this experience just 2 weeks ago. So.
Yes.
Excellent.
Right.
Well, thanks everyone. Take care.
Thank you.
Okay. Goodbye then. Goodbye.
Bye.
Bye-bye.
Goodbye.
Yes. Okay.